Hello and welcome back to Dr. Logic awkwardly does logic in her office. In this video, I'm finally going to give you that shortened truth table method that I promised you so many videos ago. The basic idea is that if you are being asked whether some arbitrary propositional logic formula is a tautology or is a contradiction or is merely consistent, you don't always want to have to write out the full entire truth table and then check the value of the formula in every single row. This is tedious. Now, logicians like tedium, but not this much tedium, because the number of rows that you have to draw on your table grows exponentially with the number of atoms in your formula. So if you only have 2 atoms, that's only 4 rows. That's not very much. But by the time that you get it to like 5 atoms, and all of a sudden you've got 32 or 64 or 128 rows, there just isn't paper big enough. And it gets kind of boring. And it's very easy to miscopy things and to, read one line when you should have read another line, and you end up with errors. So this is a more efficient way of proving whether something is a tautology. It also works for proving contradictions, because wherever I say true, just say false and vice versa. Let me bring up the whiteboard because we are going to need it. We just won't need quite as much space as we would have needed otherwise. So the thought behind this mechanism is that if I ask you, is this sentence a tautology? You can think of this as asking, is every row of the truth table true? But you can also think of it as asking, can I come up with a row that is false? So what would the row of the truth table have to look like? What would the assignment to the atoms have to be in order to make the entire sentence false? And that is a much more targeted sort of way, because you're just asking, can I find one row of the table that does what I need it to do? If the answer is yes, if you can make it false, then it's not a tautology. But if the answer is no, if you run into a contradiction, if you have to assign one and the same atom both true and false at the same time, then you do have a tautology on your hands. So let's look at this as an example. So if P, then P and not P implies Q. Is this a tautology? Alternatively, can we find a line in the truth table that makes it false? So I'm going to write it down here so that we've got plenty of space. If there is a line in the truth table that makes the main connective false, well, the main connective is this first implication. So if this is false, that means the antecedent has to be true and the consequent has to be false, because there's exactly one way for a conditional to be false. This is also an implication, and so if we know that this one is false, well, again, it has to be that the antecedent is true and the consequent is false. So already at this point, we have a truth value assignment. We have that the value of P is true and the value of Q is false. But we still need to make sure that we look at every component of the sentence to make sure that this actually works. So in particular, now that we know that P has to be true, well, we know that it's going to be true here and it's going to be true here as well. But if P is true, not P is false, and if you look at the conjunction of something true and something false, this actually ends up being false. So we needed this conjunction to be true, but it turns out to be false. So can we find a line in the truth table that makes it false? The answer is no. Is this a tautology? The answer is yes. So there's one very easy answer, or very easy example. Let me just check my other monitor, and here's another one that we will do. So I will clear the board. So another example is if J, then if K, then L, then if K, then J, then L, a tautology. So it's a string of implications, but what I've done is I've just kind of rearranged the order of the antecedents. Is this truth preserving? Is this valid? So our alternative question is, can we make this sentence false. So write it out where you've got plenty of room. So if J, then K, then L. If that's true, then is it the case that if K, then J, then L? So again, this is a conditional. Conditionals are really nice because there's only one way to make them false. So there's our main connective, we want this to be false. So that means the antecedent needs to be true and the consequent false. Now, there are many different ways that a conditional can be true. There's 3 different ways. So let's look at the consequent rather than the antecedent, because there's exactly one way that we can make this sentence false. In order for this implication to be false, we need the antecedent to be true and the consequent false. Again, the consequence is itself a conditional, so in order for this to be false, we want the antecedent to be true and the consequent false. So now we have our truth value assignment. J is true, K is true, and L is false. So we know that these atoms have to have these truth values because this is the only possible way that we could make the consequence of the entire conditional false. But let's go back here and plug these values in and see if we still have what we need to have. So J is true, K is true, L is false. If we have an implication between something true and something false, what we have is, again, false. But then we have a true antecedent and a false consequence. So that means that this conditional here, which needed to be true, is in fact false. So can we make this sentence false? No. Is it a tautology? Yes. And you might begin to think, well, is it ever possible to make a sentence false? Everything that we look at seems to be a tautology. Let's try one more just so that you can see what it would look like when you don't end up with a contradiction. So here we go. I'm just going to write the sentence out. You know what question it is that we're asking. So we have Q implies P and not Q implies, sorry, I want an implication, not a conjunction. There we go. So Q implies P, not Q implies R. If this is the case, then is it the case that we have either not P or R? So, sorry, there. If Q implies P and not Q implies R, then it's not the case that you have either P or R. That's what I wanted to say. So is this a tautology? Well, again, find the main connective. It's the implication. We want to have a true antecedent and a false consequence. Well, this is a negation. So if the negation is false, this means that the disjunction is true. There are 3 different ways this disjunction could be true. So that's wherever you can, work with the parts of the formula where there's exactly one way that you can make them true or false. So I'm going to leave the disjunction behind for now and instead look here, because we have a true conjunction in the antecedent. So that means that each of the conditionals, they're called conditionals, each of the conditionals has to be true. So now we are in a more complicated situation because there isn't any single way that we can go from here. We need to consider a bunch of different cases. So in particular, we have the, oops, I wanted a different color, there we go. We have the case where P is true and R is true, where P is true and R is false, and where P is false and R is true. These are the 3 possible ways that this disjunction could be true. Now, if we go back over here and just kind of copy the possibilities, so P is either true or false, and then over here, R is either true or false or false. Now, we need to make this conditional true. Well, it already has a true antecedent, so that's good enough. In fact, if you look at this one, we need to make this conditional true. It already has a, sorry, true consequent, not antecedent, true consequent. This already also has a true consequent. So, look at that. look at that. We have found a line of the truth table that makes this entire sentence false. So when P is true and R is true, and then we need to say something about Q, but in fact, it doesn't really matter. So the value of Q is arbitrary. Whether it is true or false, this entire sentence is going to be false and therefore not a tautology. So here's an example of something where we asked, could we find a row where it is false? And the answer was yes, so not a tautology. Because this is such a useful method, I think in my next video, I'm going to go through like one more example of this, but instead of doing it where I am kind of filling in rows in a truth table like this, I'm going to do it in a more verbose kind of written fashion where you can see the reasoning articulated explicitly at every single row of the step. Because sometimes looking at this after the fact, so after I've done drawing it out, it's hard to see how I got it because my process of reasoning was a step-by-step dynamic process, but what you see in what I've written is just this static presentation. So I will show you a way of writing down each of the steps so that it makes explicit the process by which you got each one of these values. But we'll save that for another video. For now, I hope you enjoyed the shortened truth table method. Don't worry, if you like tedium, you can draw your exhaustive truth tables with every single line out to your heart's content. But if you have more interesting things to do with your time, here's the shortened truth table method. I hope you find it useful. See you later. Cheers.